All right, guys, so what I'm going to do is I'm going to work through these problems one by one. I am recording this meeting, so if you don't catch it in real time, you can watch it later. So I'm going to start here with number 1. I do have the unit circle that I'm going to pull up and reference from time to time. So when you're taking your midterm, you'll probably want to reference the unit circle also. So that's there. So let's get started. All right, so when I'm converting from radians to degrees, or sorry, from degrees to radians, like I am asked to do in this question, you take the degree measure. So if you want radians, so I'll put a little R there to say I want radians, you take the measure in degrees, and we're going to multiply by pi over 180. So when you want radians, you want to put a pi in, and you want to take the degree units out. So that's why you know this is the one where you put the pi on top and the 180 on the bottom. So we end up with 270 pi over 180. And then we can reduce from here, guys. So when we reduce the fraction, we reduce it around the pi. So I'm going to look at the 270 and the 180 and reduce. You guys, if you take out 90, so what if I divided both 270 and 180 by 90? I would end up with 3 pi over 2. And now the 3 over 2 is reduced as much as possible. I do leave the pi in there, and my answer for my theta in radians is 3 pi over 2. All right, so next. Okay, so we're looking for a coterminal angle. Find an angle between 0 and 360 that is coterminal with 890. So if you're given an angle that's larger than 360, what you're going to do is you're going to subtract 360 until you get to an angle that's within 0 and 360. So let's see, what is 890 minus 360? And we get 530. Now, is this within 0 and 360? No, not yet. So I do need to subtract 360 one more time. Now 530 minus 360 is 170. And you guys, 170 is within one rotation, so it's between 0 and 360. So this is the answer I'm looking for. So notice no matter how many times you have to do it, you keep subtracting 360. We never subtract anything else but one full rotation. Now, this is part A. So part B, we're doing the same thing, but we're doing it in radians. So the angle given is 33 pi over 10. Now, when you're in radians, we don't subtract 360, we subtract 2 pi. Because 360 degrees is 2 pi radians. Radians are a little bit harder because we've got the fractions. I have a fraction with this 33 pi over 10, so I need to turn 2 pi into a fraction over 10 also. You know, we have to have common denominators to subtract fractions. So this 33 pi over 10 is going to stay as is. And you guys, I'm going to take it to the side. Right now we have 2 pi over 1. So it wasn't a fraction, but we can make it 1 by putting it over 1. So 2 pi over 1. I need to find an equivalent fraction with a 10 on the bottom. So to get there, on the bottom I had to multiply by 10. It just means you have to do the same thing on top. So instead of writing 2 pi, I'm going to write 20 pi over 10. It's still 2 pi, but it's a fraction I can subtract. Remember when you're subtracting fractions with the common denominator, the denominator stays the same. All you do is subtract the top. So I have 33 pi minus 20 pi, and that leaves me with 13 pi over 10. Now, it's a little harder to know if this is within one rotation because it's a fraction, But I already know that 2 pi, so 1 full rotation, is 20 pi over 10. So I'm only at 13, so that is within 1 rotation there. So that would be my answer on this one. All right, so let's look at the next question. This is a circle with a radius of 17 inches. We're looking for radian measure. Remember that theta in radians, when you do have the radius and the arc length, theta is found by S over R. S is arc length, R is radius. And we just have to make sure that S and R are in the same unit. So it says they're both in inches here. So I don't have to do any unit conversion. And to find this theta in radians, all I have to do is take S. Remember, S is just arc length. So it gives me an S of 8 and a radius of 17. Now it does say to round your answer to the nearest tenth. So I'm not going to leave it as the fraction 8 over 17. I'm going to do 8 divided by 17. And you guys, for this, I got 0.4705 or so, but to the nearest tenth, that would be 0.5. All right. Let's look at the next question. All right, so we have a circle with a radius measure again. This time we're not looking for radian measure. We are looking for the area of the sector. So you guys, to find the area of a sector, we have A for area equals 1/2 times theta r squared. Remember, your theta does need to be in radians for this. So if it does give you a degree theta here, you will have to convert it to radians. But our angle that it's given here is already in radians. So all I have to do is plug all this into the formula. So I've got the 1/2 times theta, which is 3.5 radians, times the radius squared. So the radius is 7.5, and I have to square that. So you guys, I want you to be careful in your work on this one, because you do need to square that 7.5 before you do anything else with it. So I'm going to go ahead and square that so we don't forget to square it later. So I have 1/2 times 3.5, and then I did square 7.5, and I got 56.25. Now all I have to do is multiply all this together. If you're in your calculator and you're multiplying by the 1/2, it's probably easiest to write that as 0.5 in your calculator. So in mine, I'm doing 0.5 times 3.5 times 56.25. And I get my area of this sector. It says round to the nearest tenth. So I got 98.4. And it already has the units here for you, the feet squared. So all you have to do is write in the number. So you guys, this formula, just like the last one with the radian measure being S over R, you can have this written down somewhere if you want to reference. That's totally fine. Or you might have practiced with it enough that you just know it now. But if you don't, have it written down somewhere before you start taking your test. All right, so next we have a right triangle. It gives you all the lengths of the side. So we have an 8, 15, 17 triangle here. And we're just going to find some trig ratios. So let's find the tangent of B. Remember, tangent is opposite over adjacent. And we're looking at, we're referencing angle B. So for angle B, the opposite side is 15 and the adjacent side is 8. So you would just write in 15 over 8. As it is reduced here. So if it's not, you can reduce it, but this one is already reduced. Sine B. Remember, sine is opposite over hypotenuse. So in this case, opposite is 15 and hypotenuse is 17. So I just write in that fraction. The cosine of B, so you guys, cosine is adjacent over hypotenuse. So for angle B, adjacent is 8, hypotenuse is 17. All right, so moving on. number 6. Let's see, what do we have? We have solve for x in the triangle. So we are solving for the side of a triangle. If I had this side, I could just use the Pythagorean theorem to find the other side, but I only have one side. But I do know one of the angles is 66 degrees. So guys, there's multiple different ways to do this, but I think the fastest way would be to look at this angle we have, look at the sides we have and what we're looking for, and think about a trig ratio that fits the information given. So for this angle 66, would you agree that the sine of 66 being opposite over hypotenuse would have to be x over 10? So yeah, I think that's true. So notice we don't know this angle down, or this side down here, and we really don't need to. So I am using the opposite of 66 and the hypotenuse of the triangle to do this equation here. Now from here, before I start putting anything in my calculator, I'm gonna get x by itself. So I'm gonna multiply both sides by 10. And then I'll have 10 times the sine of 66 equals x. So to find x, I'm going to put all of that into my calculator. I'll put 10 times sine 66. And what I get here, and it does say nearest tenth again, so 9.1 is what I got on that one. All right, so determine the quadrant in which the terminal side of theta lies. So you guys, on this one, we're thinking about that graph of the quadrants, or you can be looking at your unit circle, and that would help you also. I know that for each quadrant, there's a certain set of trig functions that are positive. Remember that in the first quadrant, everything's positive. In the second quadrant, sine and cosecant are positive, but everything else is negative. In the third quadrant, tangent and cotangent are both positive, but everything else is negative. And in the fourth quadrant is cosine and secant. So remember, that's where we get our all students take calculus mnemonic there. Okay, so let's look at the question at hand. It says that for part A, tangent is greater than 0. So tangent is positive and cosine is positive. So you're going to look for the quadrant where both of those are true. So tangent's positive in the third quadrant, but cosine is not. In the fourth quadrant, cosine is positive, but tangent is not. So you guys, the only time where they're both positive at the same time is in quadrant 1, where they're all positive. So I click quadrant 1 there. And then let's look at part B. So in part B, we have the cosine is positive, but sine is negative. So where is that the case? Well, cosine is positive in 1 and 4, but sine also being negative, you guys, that's got to be quadrant 4. All right, so let's go to the next one. All right, so I have a point, -4, -7 on the terminal side of theta. So you guys, when you're reading this question, if you want to think about it as a picture, you can. You don't have to. I'm sorry, just a second. I think my dog has a bottle and it's very loud. So give me a second. Gracie, it's too loud, okay? Okay. Sorry, guys, that would have been very annoying later. Okay, so -4, -7 is this point right here. When it says the terminal side of theta goes through that point, remember your thetas when they're in the plane are in standard position, which means the initial side is on the x-axis. This terminal side would be going down this way. So your theta would be here. Now, like I said, you don't have to draw a picture of this to know how to find it. If you remember from my videos, anytime you have an angle in standard position and it gives you a point that it goes through, what it's really giving you is x and y. So remember, in the plane, we have certain side ratios. They're still opposite and adjacent and I have hypotenuse, but we think about them a little differently using x, y, and r. So remember for sine theta, sine is y over r. It's also looking here for cosecant. So you guys, cosecant, remember that's just the reciprocal of sine. So cosecant is r over y. And then it wants cotangent, and cotangent is x over y. So if I remember the ratios with x, y, and r, and they already gave me x and y, all I have to do is find r. So remember always that x squared plus y squared equals r squared. So if I already have x and y, I can easily solve for r. So let's do that. It says my x is -4, and my y is -7. So I'm looking at this. You guys, when you square negatives, remember that they go positive. So I have 16 plus 49 equals r squared. So I end up with 65 equals r squared. Now I don't need r squared, I need r, right? So I'm going to square root both sides here and get that r is square root of 65. Notice I don't need a plus or minus on this square root because r is always positive. Basically, r is always this distance here. If you did want to draw a picture of this one, it's a little hard to understand where it would be, but you would drop your right triangle line down, or actually up in this case, to the x-axis. And that's something I do want to note, because sometimes people just, instead of thinking about x, y, and r the way I have here, if you really like to draw pictures of all of these examples, you need to make sure that when you're dropping your right triangle, it always goes to the x-axis, either up or down. It never, your right triangle never is going to be completed by the y-axis. So anyway, we have our r equals the square root of 65. You would definitely try to reduce that root if you could, but this one doesn't reduce, so we're going to leave it as root 65. So if x is -4, y is -7, and r is root 65, we can find these answers here. So the sine of theta, y over r, will be -7 over root 65. But we know we can't leave it like that, so we are going to rationalize the denominator. So we end up with -7 square root 65 over 65. So that would be my answer for sine of theta. Cosecant is r over y. So it's just the reciprocal of what I found for sine. So r is root 65, y is -7, and we don't have to rationalize that one. Cotangent is x over y. So honestly, we could have found that earlier before we found r. But x over y, -4 over -7. Make sure you do cancel those negatives out and just leave it as 4/7. And you guys, your question might ask for different trig functions. So you have to remember. So I've already got 3 of them here, but you guys, what if it asked for cosine? You have to know that cosine is x over r. Tangent is y over x. What's the one that's missing? Secant is r over x. So you want to remember those. You can have them written down along with any formulas if you want to. That's totally fine. All right, so let's move on. Okay, so let theta be an angle in quadrant 4. So I know that this angle is in quadrant 4 so far. And I know that the sign is -7/10. So you guys, this is another question where we're going to use values for x, y, and r. It just gives me different values to start with. So remember, if it gives you a point that the angle goes through, it is giving you x and y. If it gives you, oh, I'm not drawing. If it gives you this, like the sine of theta, for example, which two values is it giving you? Well, it depends on this function, but because it's giving me sine and I know sine is y/r, it's giving me y and r. So there is a negative in front of this one. Should I put it on top with the y or should I put it on bottom with the r? Well, you guys, I know it goes on top with the y because r is always positive. So y has to be -7 and r is 10. Now, in this problem, I need secant, and you guys, secant has an x in it, so and tangent does too, so I am going to have to solve for x before I find these two answers. So remember, x squared plus y squared equals r squared. And then I put in what I know. So I don't know x, so I'll leave it as x squared plus -7 squared equals 10 squared. So I have x squared, remember -7 squared, sorry, that's a plus, is 49. So x squared plus 49 equals 100. Let's subtract 49 from both sides and get x squared equals 51. Square root both sides of that, and you get x equals plus or minus square root of 51. Now, if this was r, I would say it's definitely positive, but it's not. X can be negative or positive. This is where you go back and look at what quadrant you're in. So guys, the value of x in quadrant 4, you guys, those values are positive. So I know because I'm in quadrant 4 that my x value is positive, square root of 51. And you guys, again, simplify this root if you can. This one is definitely not simplifiable because 51 is prime. Okay, so now that I have x, I can solve for secant and tangent. So secant, you guys remember this is the reciprocal of cosine. Cosine is x over r, so secant is r over x. So I know r is 10, x is the square root of 51. And again, we have to rationalize this top and bottom by that square root. And we'll get 10 root 51 over 51. So this is the secant of theta. And let's find the tangent. You guys, tangent is always y over x. So y is -7, x root 51. Again, with the rationalizing. You guys, after a while, you always know how this rationalizing is going to work out. You're going to put the root on top. The number is just going to be without the root on the bottom. So here's the tangent. All right, so let's do the next problem. All right, so you guys, this one is just looking at the unit circle. So here's my unit circle. It wants me to find the sine of 4 pi over 3. So all I have to do, guys, is find that angle on the unit circle. So I've got this one here. Remember that on the unit circle, sorry, hold on. There we go. On the unit circle, when you're looking at that, because r is 1 for all of these terminal points, you know that sine is just the y value and cosine is the x value of each of these coordinates. So for 4 pi over 3, I look at my coordinates. I'm looking for the sine, so I'm just looking for the y value. So it's right there, -√3 over 2. So I would just say the sine of 4 pi over 3 equals -√3 over 2. All right, so moving on. I'm about halfway done here. All right, so odd and even functions. You can have these referenced if you want to, if you can't remember which one's which. But you guys, to remember which things are odd and even, just remember that cosine and secant are even and everything else is odd. So for this question, it says secant. Is secant odd, even, or neither? Well, secant is even because it's one of the two, right? Secant and cosine. Now, cotangent. Is it secant or cosine? No, so it must be odd. Now, we have to remember how odd and even functions work. So if you're looking at an even function like secant, we have secant of negative 67 degrees. Where does the negative go in an even function? Well, if you have a negative in your input angle and you have an even function, you can just take it out. So the secant of negative 67 is going to be the exact same value as the secant of positive 67. So notice, I didn't just move the negative, I absolutely took it out of the equation. So I would pick secant 67, negative removed. But what about cotangent? Cotangent is an odd function. So when you have a negative in your input angle and you're dealing with an odd function, you can't just make the negative disappear like the even. With the odd, you can take it out though. You just have to stick it in the front. And I know it doesn't seem like that's much better, but guys, when we're working problems, having a negative angle in your trig function here is a problem. It's often a big problem. So being able to take it out and put it in the front is very helpful. So for this one, you'd click the one where the 3 pi over 10 is positive in there, but the negative is out in front. All right, so we're graphing now. Let me get my mouse out. Actually, I'm going to draw first, guys. So you guys, so this wants you to graph, there we go. I want you to graph 5/2 cosine x. So all this is, you guys, how does this differ from y equals cosine x? Remember, this is just the basic version. The only difference here is we have the 5/2. Remember, that's your amplitude. So it means that normal cosine goes up to 1 and down to -1. But instead of that, we're going to go up to 5/2 and down to -5/2. So I am going to start by drawing in normal cosine. So remember, we have 5 important points for normal cosine. We start, okay, sorry, I keep doing that with my hand. Okay, so we start here. It hits a high point at x equals 0. It hits the x-axis at pi over 2. How do I know pi over 2 is right here? Well, you guys, these graphs are, their grid units can change, so you really need to be careful. This is pi, and 1, 2, 3, 4 unit, or 4 grid squares for each pi. That means each grid square is pi over 4. So this is pi over 4. This is 2 pi over 4, or pi over 2. This is 3 pi over 4. This is 4 pi over 4, or pi. So pi over 2 is here. You guys, cosine hits a low point at pi, goes back through at 3 pi over 2, and then a high point at 2 pi. So you guys, this is not your answer. This is normal y equals cosine x. Now, I need y equals 5/2 cosine x. So when I go to graph my actual answer here, I just need to make sure I go up to 5/2. I don't exactly know how to graph on here. So go up to 5/2. Now, your intercepts aren't going to change, right? Amplitude doesn't affect those. So down to -5/2. Up through the intercept again. and my 2 pi value is going to be up at 5/2. And now I think I clicked that. Yep, so look, you can see my basic cosine here. And look what the amplitude did. It just made it go higher and lower, but it's still hitting the high points at the same x value. And it's still hitting the same x-intercepts. Okay, moving on. All right, so on this graph, notice we are just looking at the basic sine x. I know what that looks like. What is this plus 3 doing? You guys remember this 3, it's not inside the sine function, it's just sitting on the outside at the end. That means it's a vertical shift. We're going to go up 3. So let's start by drawing in basic sine. Now look at your grid marks. Make sure that you know how many units each of these squares is. So 1, 2, 3, 4 to get to pi. So it looks like it's the same as the other one was. It's in units of pi over 4. So what does sine look like? You guys, it starts at 0, 0. It hits a high point of 1 at pi over 2. At pi, it's back to 0. At 3 pi over 2, we're down at -1, and then back to 2 pi at 0. So you guys, here's basic sine. So how is our graph going to look different from this? Well, it's going to look just like this, except for every single point moves up 3. So this is not stretching it like amplitude and leaving it on the x-axis. This is actually picking it up and moving it up 3 units. So I am going to put my mouse on. So this point that was at 0 is now going to be at 3. The high point, it used to be at 1, now it's at 4. For pi, back to 3. For 3 pi over 2, down to 2. No, I didn't get that one. And then 2 pi, back to 3. And let's graph that. Oh, it didn't catch my last point, so let's get that in there. Okay. So yeah, so you can see normal sine here. All I did was pick it up and moved it up 3. Okay, moving on. No, mouse. There we go. All right, so on this one, guys, we have an amplitude change and a phase shift. Remember that the phase shift is picking my graph up and moving it just like the vertical shift was, but it's a right and left situation. So you guys, this 3, first of all, my amplitude is 3. So it's going to go up to 3 and down to -3. This phase shift here, the -2 pi over 3 that it's given me, well, remember that the phase shift is always C over B, but notice our B is just 1 here. So it's really just going to be 2 pi over 3. And then the sign on it, you guys, this minus here actually is going to tell me to go right. So I'm going to leave this as positive. I'm changing the sign. So when you have that question where you have to write what the phase shift is, you see a minus here, your answer is going to have a positive. It's just saying that we're going to the right. We're going in a positive direction. Okay, so let's get started on this one. Notice first, before I even do anything, notice your grid squares, well, they're not even squares, are different units. There's 1, 2, 3, 4, 5, 6 units from 0 to pi. So it means that each one is pi over 6. So we're going to keep that in mind as we start graphing. You guys, I'm going to start by graphing basic sine here. Remember, you don't have to. So you guys, if there's 6 marks here and I'm looking for pi over 2, so I'm looking for half of this, I've got to go to 3. Here's 1. So we hit that, we hit that, we hit that, and we hit that. So here's normal sine on this graph? I need to do two things. I need to send it up to 3 and down to -3. So let's do the amplitude first. All I'm doing here is changing the amplitude. And remember, I would be doing this on paper if I were you. Remember, you are going to be turning your paper in anyway. So I want to see your work on these. If you do it all in one step, I guess that's fine. I really want to see your steps, however many you take. So you guys, here's amplitude of 3. Okay, so that's where we are. Now what do I need to do? Phase shift, pick it up and move it to the right 2 pi over 3. That means every single point has to move 2 pi over 3 to the right. And that seems a little difficult, but that's the reason why we're in units of pi over 6. Remember, every one of these squares is pi over 6 on the x-axis. So I have 2 pi over 3. Well, how many pi over 6s is that? Well, that's what I need to find out, because that's how many squares I'm going to move everything over. So on bottom, that would be times 2 to get to the 6, times 2 on top, and we get 4 pi. Hold on just a second, guys. Dad, can you call Grandma? She just called twice, but I'm in a meeting. Talk to her. Put it to your ear. It's not on speaker. Okay, sorry guys. So 4 pi over 6, that means every time I want to move over 2 pi over 3 units to the right, I have to go 4 pi over 6 units. So I have to go 4 of these squares. So I'm going to draw. So you guys, I have this point at 0. Remember, all the points move. So I'm going to send it to the right 2 pi over 3. I found that that was 4 pi over 6 units. So 1, 2, 3, 4. Now it's going to be here. From there, take your next point. So we had this high point at 3. Move it over 1, 2, 3, 4. Now we're here. From there, it didn't get that point in there. There we go. From there, go to this x-intercept. Move it over. 1, 2, 3, 4. Now it's here. We had our low point. Take your low point. 1, 2, 3, 4. And it's here. And then your last intercept. 1, 2, 3, 4. Now it's here. Put in the graph. So, you guys, I know this is a little difficult on this one because it's multiple steps, but if you notice from my graph with the amplitude of 3, it looks exactly the same as my answer graph. It's just shifted over 2 pi over 3 every point. So, we're getting there, guys. We're on number 15. So this one you don't have to graph, and that's good because it's a whopper, right? You guys, what is the amplitude? Remember, amplitude is here. It's always this value multiplied in front. Remember, if there is a negative on this value, your amplitude is still just the positive number. Our amplitude here is 1/2, and it's already positive. Phase shift. Remember, phase shift is always C over B, and then we'll decide if it's plus or minus. So you guys, I do have a C and a B on this one to look at. Remember, I'm not concerned with this until the end when it tells me which direction to go. So C is 3 pi over 2. So I put that on top. What is B? You guys remember B is anything that's multiplied by the x. So basically, coefficients of x. Remember, this pi is just a number, so don't leave it out. Don't say that B is just 2. B here is 2 pi. So I have to divide here. 3 pi over 2 divided by 2 pi. Remember, this is 2 pi over 1. we are dividing fractions here, so let's call this 3 pi over 2 multiplied by 1 over 2 pi. So see what I'm doing here? Instead of dividing by a fraction, I'm multiplying by the reciprocal. These pi's cancel each other out, which is nice. And straight across the top, straight across the bottom here, I get 3/4. So you guys, my phase shift is 3/4. Remember, the sign I put here indicates the direction it moves. So this is a minus. What does a minus tell me to do? It tells me to go to the right. So I'm going to leave this as a positive 3/4 because my phase shift is 3/4 to the right. So just think always changing the sign on that. But don't say that the phase shift is just C. Remember, it's always C over B. All right, so the period. All right, so the period of this function, remember it involves B, but it is not B. The period is always 2 pi over B. All right, so B is 2 pi, right? I used that in the phase shift. So 2 pi over B is 2 pi over 2 pi. What's that, guys? Fraction with the same thing on top and bottom is 1. So you guys, your period for this one is 1. All right, so we're looking at an inverse function. So that was something new from this week. You guys, just remember that the inverse functions are just using the functions backwards. So while I might say the tangent, oh, I'm not drawing, there we go. I might say the tangent of some angle theta equals -√3. Well, if I want to find this angle, I'm going to say, okay, well, the inverse tangent of -√3 is this angle. So it's a little bit backwards. It's when you know the output, but you want to find out what the input was. Okay, so you guys, it is best to reference the unit circle when you're doing these problems, but you do have to keep in mind the ranges of your inverse functions. So just remember, if you're looking for inverse tangent, the quadrants you get to look in are quadrant 1 and quadrant 4, but it's not the quadrant 4 that's on your unit circle. It's the negative angles, like if you were to start at 0 and go down clockwise. So let's keep that in mind. You guys, for inverse sine, it's exactly the same range. You're either going to get a value from quadrant 1 or quadrant 4, but those negative values. So when I say the negative values, I mean instead of 330, it would be -30, just a different rotation. But you guys, if you're looking for inverse cosine, and I'm giving you all three because I don't know which one it's going to ask you. Inverse cosine is coming from quadrant 1 or quadrant 2, not negative angles at all, just quadrant 1 and 2. Okay, so let's look for this one. I am looking for a tangent of -√3. So I'm going to go to my unit circle. Let me clear all that. All right, so here's the problem. My unit circle has sine values and cosine values very explicitly, but it doesn't explicitly have tangent values. So you guys, at this point though, you should know where tangent equals the square root of 3 or the negative square root of 3. Because remember, tangent, hold on, tangent is y over x. So to get a square root of 3 as a tangent, just for example, y over x. You guys, if you have √3 over 2 over 1/2, like we do at pi over 3 or 60 degrees, these two denominators are the same, so they cancel out. What do you get? That's how you get your √3. It's when y is √3 over 2. So you look for values like that. Now, we do need a negative √3. So I just found that for pi over 3, tangent is positive root 3. Where is tangent going to be negative root 3, guys? Well, it's going to be, yes, definitely the second quadrant would give you a negative value, but I can't look at the second quadrant because it's not part of my range. I have to look at the fourth quadrant. You guys, I think it's going to be right here. So the tangent here at this angle, now this is 300, that's the positive version, right? What's the negative version? You guys, if I started at 0 and I went down, you guys, that's going down 60 degrees. It's still a reference angle of 60 degrees. We're going to call this negative 60 degrees. It does have a tangent of negative root 3. You can see the y over x here, and when it simplifies out, it becomes negative root 3. So you guys, my answer is going to be this negative 60 degree angle. What is it in radians though? Because it asks for radians. So you guys, you know 60 is pi over 3. So negative 60 is negative pi over 3. So let's go back to our work. And you guys, this is where you would say theta is negative pi over 3. So these questions are kind of inspection, but you do have to know which quadrants you can look at, which ones are part of your range and which ones are off limits. All right, so these are straight calculator work, guys. Go to your Alex calculator. Inverse cosine of negative 1.82. You're just gonna put that in here. Inverse cosine. Oh, what did I do? There we go. Negative 1.82. I don't know what keeps happening right now. Okay, there we go. And get an answer. So you guys, do you think we made a mistake when we put this in? No, we didn't. Why did we get an undefined here? Well, because remember, what is this asking? It's asking us, hey, where is there an angle where the cosine is negative 1.82? Well, you guys, the cosine is never negative 1.82. We just saw from graphing that cosine can only take on values between 1 and negative 1. So if you're asking me to find an angle where the cosine is less than negative 1, that doesn't exist. So that's why you're getting undefined. So if you have a question, you put it in your calculator correctly and you get undefined, just say it's undefined because it's probably right. Let's do the next one. All right, so on this one, I've got inverse sine of 0.78 equals, and we get an answer there. And so you put in that answer, rounding to the nearest hundredth, I would put in 51.26. Too easy. Inverse tangent, negative 3.51. This one, while you might look at it and say, oh, it's less than negative 1, remember tangent has a range of everything. So tangent values can absolutely take on any value. So you would write in negative 74 point, well, you'd have to go 0.10 here, rounded to the nearest hundred. But I think you can handle calculator business. So let's move on. We're almost done, guys. All right, so simplifying expressions using those identities that I showed you in the last video. You can have these referenced if you want to, if you need to, but we're trying to simplify. You guys, a really good rule, if you're trying to simplify an expression and you're not sure how to start, a good place to start is to turn everything into sine and cosine terms. So when I look at secant, I'm going to rewrite that. Remember that secant is the reciprocal of cosine. So I can write it as such, as 1 over cosine. So how do I write tangent in terms of sine and cosine? Well, tangent is sine over cosine. That was your quotient identity. And again, you can reference those if you want to. You can have them written down if that helps. And then you guys, I'm looking at a complex fraction. What do I know? What have I said before about complex fractions when the denominators are the same? You guys, they are going to cancel out. Whether you flip and multiply and cancel them there, or you know what's going to happen and cancel them here. They're going to cancel out. So if those cosine denominators are gone, what are we left with? Just 1 over sine theta. And then look how it wants your answer. It says it should be either just a number or a single trig function. So what I'm going to do is I'm going to make this slightly more simplified. You guys, 1 over sine, in other words, the reciprocal of sine, right? So I would call this cosecant. And that would be my simplified answer because it's a single trig function. While 1 over sine is pretty simplified, it is a single trig function and then just a number. We just want one term here. All right, so let's see what we got next. So you guys, you'll notice that on your homework, I gave you some identities that you had to prove on your own, like you have to come up with all the steps. But sometimes that can take a long time. And I wanted you to not have to worry about that on your exam. And Alex had these nice questions where it does the steps for you, and all you have to do is tell why each step happened. So that's the question I decided to put into here. So let's look at this one. In the first line, we have secant squared minus 1 equals cosine squared. Or sorry, I said equals. Secant squared minus 1 times cosine squared. Now, remember our goal here. We're trying to take this side and make it look like this side. And you can see through all these steps that this is where they ended up. But why did they go from here to here? So you guys, usually when it's a squared involved, it's going to be the Pythagorean identity. That's going to be the rule you use. And that is the case on here too. So what I know is that tangent squared plus 1 equals secant squared. That's a Pythagorean identity that you should have written down. You should be referencing that when you're taking this midterm. How did they get what they got? Well, they just isolated the tangent squared. You can always work an identity to make it look like you need it to look, as long as you follow the rules of equations. So what I just did was I played with the Pythagorean identity. Secant squared minus 1 does equal tangent squared. So that's how they got from here to here. How did they do it? They did what I just did. They used the Pythagorean identity. So I put that there. Now, how did they get to the next step? From tangent squared to sine squared over cosine squared. Don't we have this one? You guys, this is a quotient rule or a quotient identity. Yes, we have squareds in the problem, but that's okay. The quotient identity still stands. This could be tangent to the 5th equals sine to the 5th over cosine to the 5th. It would still work as long as they're all the same power. So you guys, tangent equals sine over cosine. That's a quotient rule. So that's the rule they used there. So I click quotient. Now, how did they get to this last piece? Well, it looks to me like they put, since this is a fraction, they put this over 1. They canceled out these cosine squareds and they were left with sine squared. You guys, that's not a trig rule, right? That's just algebra. So you have to be able to recognize when it's just algebra. But that's how they got there. So let's move on. We've just got 3 more questions left. So this is gonna, so it's gonna take about an hour, it looks like, for me to go through these with you, explaining all my steps. So that should give you, usually if I take an hour to do it with explanation, you might give yourself maybe an hour 15 to an hour and a half to do it on your own, because while I'm explaining things, it does take me longer. But that's a good idea if you want to know how long it might take you to take the test. Okay, so domain and ranges. So you guys, you can have these referenced if you want to. I like to just memorize them, but I did write them all in one of those videos. And if you don't have them referenced, you can always figure them out. You guys, so the domain, remember the domain is everywhere where a function is defined. So where does secant exist and where is it undefined? So what is secant in x, y, and r terms? Or no, not, well, yeah. So you guys, I'm going to do the secant equals 1 over cosine. That's how I'm going to look at it this way. So secant being 1 over cosine, where would it be undefined? Well, if cosine ever equals 0, secant would be undefined. So my domain needs to be everything except those places where cosine equals 0. So you can look at your unit circle if you want to see where cosine equals 0. Since you have it here, remember cosine is x. Here's a place. Here's a place. It looks like the pi over 2's to me. So if cosine equals 0 at the pi over 2's, that means for secant, the pi over 2's are going to be a problem, right? So when I look at my domain here, I am looking for a set of real numbers except for the pi over 2's. What about the range of secant? Remember that cosine and sine stay within 1 and -1. But secant and cosecant are everything on the outside of that. If you want to, picture the graph. So here's 1, here's -1. Sine and cosine live here between 1 and -1. But secant and cosecant live here outside of 1 and -1, right? So because they're the reciprocals of sine and cosine, both secant and cosecant have a range of, it's going to be less than -1 or greater than +1. So you're going to click that one. Let's look at y equals tangent x. So to find its domain, like I said, if you don't just have it memorized already, tangent is tangent is cosine over sine. Where's tangent going to have a problem? It's going to have a problem where sine is 0, right? If sine was 0, tangent would be undefined. So I need to exclude anywhere where sine equals 0. So let's go back to your unit circle. Let me clear all this. So on my unit circle, where is sine 0? Remember, sine is y. So I'm thinking at the pi's. So if sine is 0 at the pi's, that means tangent is going to be undefined at the pi's. So let me go back to my work. I'm going to pick a domain of everything except for the pi's. Now remember, the range of tangent and cotangent alike are both the easiest because the range for tangent and cotangent is everything. You guys, tangent can take on any value and cotangent is the same way. All right, so let's look at cosine. You guys, the domain of sine and cosine are everything. There is no place where sine and cosine are undefined. If you want to know why that is, it's because it's the only two functions that can't be expressed as quotients of other functions. So, like the reciprocal, we have 1 over cosine, 1 over sine. When you have a denominator, there's places where that could be undefined. But when you talk about sine or cosine, that's the only way you can write those is sine and cosine. They don't have a function in the denominator. So their domain, both sine and cosine, is all real numbers. Their range, though, remember their range is the most restricted. It's the ones, between 1 and -1. So guys, other than just talking through and explaining those through, or just having them written down, you know, there's not really any work involved in these. So let's move on to the next one. All right, so on this one, I am looking for the tangent of theta. So this kind of is what seems out of order. It seems like it should have been at the beginning. But let's go back to what we first learned about tangent on a right triangle. Tangent is opposite over adjacent. So here's theta, opposite is 24. I don't know what the adjacent is. Uh-oh, I've got to find it. You guys, I can use the Pythagorean theorem to find this missing side, right? Yeah, so this one almost seems too easy. It's just out of place. Remember Pythagorean theorem, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. Lots of different ways we can see it here. But you guys, note that you do have the hypotenuse. You need to make sure that goes on the side by itself. So let's say I don't know A or B. It doesn't really matter which one's which. So I have this, a squared plus 24 squared equals 25 squared. So let's see, what's 24 squared? Where is my calculator? I should know this, and I do, but I always second guess myself when I'm teaching because I feel like I'm gonna make a silly arithmetic mistake, and if I do, then it just messes everything up, right? So anyway, so I'm double checking my whole life here. All right, it's exactly what I thought it was. Sorry, this is a plus here. A squared plus 576 equals 25 squared, which is 625. So we're here. So I need to subtract 576 on both sides. And then when I take that 625 minus 576, you get 49. And that's good because then remember you do have to square root both sides to get A. You know it's going to be positive because this is a triangle and you're looking for a side length. So you get A is 7. So here we are at 7. Now you should be able to find the tangent pretty easy. It must be 24 over 7. And it says exact value, so you would write in as a fraction. All right, next. Ooh, I wonder what a stamp is. Oh, how fun. Look, stars. Okay, anyway, let me clear that and get back to being an adult. All right, so last question, guys. This is about complementary angles. Oh, I'm still making stars. That's what I get. All right, so this is about complementary angles. And you're just answering, I mean, it seems really easy. It's really a concept question. So you guys, I have sine of angle X. So here's angle X. Sine is opposite over hypotenuse, right? So for angle X, opposite is X, hypotenuse is Z. So sine of X is X over Z. Then it wants to know the cosine of Y. So angle Y is down here. What is cosine? It's adjacent over hypotenuse. So the cosine of Y, for Y, X is adjacent. So the cosine of Y is also X over Z. What's the sine of Y? So still on angle Y, but this time the sine. Remember, sine is opposite over hypotenuse. For angle Y, Y is opposite. So I get Y over Z. Cosine of angle X is last. Back to angle X, but this time I need adjacent, which is Y, over hypotenuse, which is Z. So you guys, when you're doing this problem, this line should have the same values and this line should have the same values. And that's kind of the point. We're pointing out this relationship. And then you answer the questions below using what you found or just using what you know. You guys, the cosine of x and the sine of y are the same. One way to remember this is remember that in this right triangle, because this part is the right angle, x and y are complements of each other. They're always going to be complements of each other, the other two angles in a right triangle. So the cosine of x is the sine of y, or the sine of its complement. Remember, this is what we called the cofunctions. Sine and cosine are cofunctions, and that's why this is true. The sine of x is going to be the cosine of its complement because sine and cosine are cofunctions. And then one that we have to do with exact values, we have the cosine of 47. That equals the sine of what? Well, remember, cosine and sine are cofunctions, so the cosine of an angle will equal the sine of its complement. How do you find its complement? You do 90 minus. So what is 90 minus 47? Yeah, it's going to be 43, right? So the cosine of 47 equals the sine of 43. You just do the 90 minus and you get your answer there. All right, guys, well, it's looking like that's it for this test. So look over this, let me know if you have any questions, but this should help you get through your practice midterm. And remember, you can take it as many times as you want. All right, so that's it, guys. I'll see you later.